What is going on YouTube? I'm Present Arms here, and I'm bringing you a gameplay commentary on the map Hazard. I'm playing some free for all. I go 30-4. I am using the FAMAS red dot. Anyway, that's all I'm going to talk about with the gameplay for today. What I am here to talk about is a new series that I'll be starting, and it's called like Scientific, since today is Saturday when I'm making this commentary. It's 11:06, so like it'll be Scientific Saturday or Scientific Sunday, Monday, whatever. So basically, if you don't know, I love science. I love it, I love it, I love it. It explains everything, not everything as in, you know, some stuff, but it tries its best, and as science gets more advanced, it will help explain the natural world and everything else. Love it, I love it, love it. And so each day, not each day, but because I have to work, so I can't do a commentary every day. I might have homework, but when I try, and I feel like doing it, I will do like a day where I talk about a specific subject in science. And for example, today I will be talking about quantum mechanics, which is kind of complex for the first time doing it. So I'll go in depth, but not entirely in depth, but just about 6 minutes in depth basically. But anyway, I just want to tell you that's what I'm going to be doing. Hopefully, maybe on Mondays I might do a Myth Monday, where I'll talk about a really well-known myth that people believe is fact, but it's actually not. I'm still going to try to do MLG Mondays or MLG Tuesdays. I'll just try to mix it up, where whatever day it is, I'll say MLG Tuesdays or Scientific Thursdays or something like that. Try to do my best on having good topics. If you're interested in science, you know, and you like what I'm doing, starting to do, just put like some topics I could talk about. I have a couple that I know that I'll probably start talking about. So basically, today we're going to talk about quantum mechanics. And quantum mechanics is very, very complex. It's very, very complex. It's basically the mechanics of particles and how they can act as a wave and a particle, and sometimes act as wave, sometimes as a particle. There's a double slit experiment done with photons, which is particles of light, and it basically showed that some of the photons will go through this way and wind up way there's like a sheet or like a fabric, some kind of material that captured them and showed up on the computer screen where the photons landed, and they had two slits. There was 2 or 4. They had slits, and they'd shine a packet of photons, and some photons or particle, it's photons, a light particle. Well, some of them will go exactly where they predicted, and sometimes they go, well, I mean, they don't even know how it even winded up. But there was one part that didn't have the little slit, and it was just a wall, and it ended up behind that on the fabric. It's crazy, crazy stuff. But basically, you cannot precisely say where a particle is in space. You cannot say it's here. Before quantum mechanics were, came up with, they had I don't know if you know who Niels Bohr is. He was a physicist, and he came up with the model of an atom. You've probably seen it in school, but it's basically we have the protons and the neutrons, and then you have like orbits around the electron orbital. Well, that is very, very unscientific. That's actually not how atoms will look. If you could actually, you can see atoms, but you can never see it's hard to see the electrons. Really, really, that you can see some of them if you have electron microscopes, but Niels' model just showed how many the energy levels of the electrons. Like there's 2, and then 8, and then it keeps on going. And it's basically trying to say an element how many they have, but that's actually not what an actual atom looks like. An actual atom has electron clouds, which is basically where the probability of electron being in this specific area, like it's kind of like a circle around it, but it kind of overlaps and goes out. But the probability of that electron being there is basically what it is. Like it could be here or it could be there in this specific cloud, but it won't go outside of it. And you have some electrons, like this is the first 2 are 8. The first orbit is 2, then the electrons will not be outside that cloud. They won't you can't say what's right there, next to that other electron. No, you cannot say that. They're somewhere in that cloud, and then the next 8 are somewhere in that specific cloud, but not the same cloud as the first 2. All the Bohr's model showed was just the electron energy levels. But basically, quantum mechanics is that how waves can act as particles can act as waves and as a particle at the same time, where you can shoot particle land here, or it can act as a wave, like white light will act as a wave and a particle, not at the same time, but every other. You can never see, like with Newtonian physics, you can, if you throw a ball at this angle and it'll land, you can predict where it lands. With quantum mechanics, you cannot predict. The only thing you can do is say the probability of a particle is this, and the math is crazy with quantum mechanics. It is really complex. Like, it is, just craziness. Just like, you can't say, well, atom's gonna be at X, Y, and Z in this part. No, it's like the probability will be this, like -1. This is it's crazy stuff. That's pretty much all the time I have for it. If you want me to go more in depth in quantum mechanics, there's a lot more. We just skimmed the surface in this commentary. Please let me comment in the comment section. Please comment, rate, subscribe. It helps me out a lot. And thank you for watching. I'll see you in the next video.